right, let's look at the BC specific questions of the 2023 AP Calculus exam. This is BC question number 2, and this is a calculator active question. I have not read the question yet, so you get to see me read it and problem solve it in real time. This may lead to me having to pause and think for a few minutes on some parts. We'll see how that goes. So let's look here. Let's see, we have a graph. What is this? Particle motion, parametrically defined. They tell you y is 2 sine t. Then they give you dx dt, which is e to the cosine t. Those are fairly clean functions. I don't think I'm going to bother saving those in my calculator. They're not ugly enough that I can't just enter those each time I need it. At time 0, the particle is at the position 1, 0. So I'm going to do a little bit of game planning here, just a little bit of pre-work. So I know that y of t is equal to 2 sine t. They tell you that dx dt, which I'm going to call x prime of t, is e to the cosine t. And then they give you an initial condition. They tell you that the y, I'll also do x coordinate first. The x coordinate at time 0 is 1. The y coordinate at time 0 is 0. All right, find the acceleration vector at time 1. So this is a nice question, and show the setup that leads to your solution. So there's not a whole lot for you to do setup-wise, and you don't even really need a calculator. This is so clean. Oh, acceleration, we need the second derivative of y, don't we? So that would be the acceleration vector would be the vector y double prime of, we're at 1, right? Y double prime of, why am I putting y before x? What am I doing? X double prime of 1 and y double prime of 1. And I think I will just go on and use my calculator commands for this one. And so I need to, do I want to store those? You know what? I am. I said I'm not going to define those. I think I will. So I'm going to define y of t to be, it is the function 2 sine, I forgot to put the equal sign, equals 2 sine t. So there's my y define. Okay, now x is a tricky one. It's the derivative of x. I wonder if I can do x prime of t equals, I don't think this is going to work. I think I'm going to blow my calculator up here. E to the cosine t. Oh, I know what I can do. Yeah, I didn't think that was going to work. So let's escape. I'm going to call it dx of t. Dx, so the derivative of x of t. So dx of t is e to the cosine t, and that will work. And I'm going to make note on my written work that this x prime of t is stored for dx of t in the calculator. Okay, that way I can keep that straight. Now I need to compute the first derivative of dx to get x double prime. I need the second derivative of y to get y double prime. So I'm going to go menu, calculus, derivative at a point. And I'm going to stick with t's. I need to plug in 1 to the first derivative of my dx of t function. And I'm getting that, which I think I'm just going to go on and get the decimal. Negative 1.444 is the x component. Oh, let's go back to blue. Negative 1.444. And for y, I can do menu, calculus, derivative at a point. I'm going to use t. I'm going to plug in 1, and I'm going to choose the second derivative. The second derivative of y of t. And I'm going to go ahead and hit Control Enter to force the decimal. That is negative 1.6829. And I'm going to go ahead and write all 4 of those. Negative 1.6829. You can round that up to 683, or you can truncate at 682. I guess I'd be rounding down since we're negative. Anyway, so there's your answer for A. Very nice question. By the way, the vector motion, the parametric motion problems are typically very nice. For 0 to pi, find the first time at which the speed is 1.5 and show the work that leads to your answer. So your speed is the function square root of x prime of t squared plus y prime of t squared. And if you want to, I can plug x prime is e to the cosine. And I'm really wasting time here. I don't need to do this. Plus y prime is going to be 2 cosine. Man, I'm being very daring, very daring. And that is my speed. The way you compute speed, we need that to equal 1.5, and we will solve this graphically. So I'm now going to go to my calculator, and that is x prime, that is dx of t. So to my calculator, I need a giant square root of dx of x. And remember, in your graph screen, you have to use function x. So dx is x prime. I need to square that, and then plus the derivative of my y function, which is the quantity of 2 cosine of x squared, dx of x. So that's my x prime. I squared that. The derivative of 2 sine is 2 cosine. I have to use x's since I'm graphing in the calculator. That looks good. I'm going to graph that one, and then we need that to equal 1.5. So now I will graph the horizontal line, y equals 1.5, and it looks like this. One thing I don't like about the Inspires is it puts all my labels right smack dab on it. It looks like it's that point slightly after 1. I'm going to double check the interval the first time on the interval 0 to pi, and so that would be between 0 and pi. So I'll go menu, analyze, intersection, and boing, there's my answer. It's 1.254. I don't know if I'm going to need this later or not, so I'm going to go ahead and store that value in my calculator for A, just in case. So A is 1.254, and that is the solution. So this happens at t equals 1.254, which I'm now going to say let A equal 1.254, just in case I have to use that later on. Probably not really expecting it. Find the slope of the line tangent to the path of the particle at time t equals 1. Find the x-coordinate of the position at time 1. So we have 2 questions in one that are fairly independent of each other. The slope is always going to be dy, a change in y over a change in x at t equals 1, which is going to be, in the world of parametrics, y prime of 1 over x prime of 1, which would be, and I can go to the calculator and do this. Now again, y prime is so clean. Y prime is going to be 2 cosine of 1. That's 2 cosine of 1 over x prime was given to us. That would be e to the cosine of 1. And honestly, you can stop there. That is an acceptable answer. If you want to punch that in the calculator, you can. I don't see any advantage to that, but what the heck? Let's do it. So control divide. It was 2 cosine of 1, correct? 2 cosine of 1 divided by e to the cosine of 1. And I am double checking. I am in radians. That would really screw everything up. Control enter to force the decimal. That is 0.6295. But I'm going to draw a line through that because I have an acceptable numeric answer just before, and just in case I fat-fingered something in the calculator, I don't want that to count against me. We also need to find the x-coordinate at time 1. So this is part 2 of number C. So x-coordinate at time 1, we have the initial x-coordinate at time 0. I need to see how much x changes on the interval 0 to 1, which will be the antiderivative from 0 to 1 of x prime of t. X of 0 is 1. So I'm going to do 1 plus that definite integral, which is very nice. So 1 plus shift plus the integral from 0 to 1. And x prime is stored in my calculator as dx of t dt. I'm going to hit control enter to force the decimal, and I'm getting 3.3415. Very nice question. These the particle motion problems in BC do tend to be very nice. Of the BC specific topics, I think these are the nicest to work through when you compare it to like polar and series and stuff like that. That find the total distance traveled. Again, these are nice. Oh, this is so nice. Y'all should be thankful. Yay, particle motion. I hope you had form O because this is a nice one. I know a few of my students had form E, so I'm sorry. Total distance is just your arc length. Arc length. So we're going to go 0 to pi of the square root of x prime of t squared plus y prime of t squared dt. And we will throw that in the calculator. And you always show your setup. They were nice enough to say, show the setup. They don't have to say that. You always should know to show the setup of your answers, especially on the calculator active questions. So that's 0 to pi of giant square root of dx of t squared plus dy, or y prime, which again is 2 cosine of t squared dt. A lot easier to type this in when you have a keyboard. And I believe that is all correct. I'm looking for errors. I don't see any. Control enter to force the decimal, 6.0346. And I am writing the fourth decimal on all of these, 6.0346. Is that what I said? I'm writing the fourth decimal on every one of these because it appears that they all give you the option, except for, I guess, B. You have the option of rounding, following standard rounding procedures, or truncating. So there are two acceptable 3 decimal answers for parts C and D, and for the Y component of part A. So there is all of this one. I don't think I made any mistakes, and that fits very nicely. There's not a whole lot of work to do as far as pencil to paper time. It's all in the calculator. And that is it for question number 2 on the BC exam.